Example number 2. The 64.4 pound crate slides down the curved path in the vertical plane. If the crate has a velocity of 3 feet per second down the incline at point A and a velocity of 25 feet per second at B, compute the work U sub F done on the crate by friction during the motion from A to B. So the question is the work done on the crate by the friction force during the motion from point A to point B. So again, let's write out the given. The mass is 64.4 pound. The velocity at point A is 3 feet per second. The velocity at point B is 25 feet per second. For the required, that would be U sub F. And let's go now to the solution. So let's use the equation T1 plus the work done from point 1 to point 2 is equals to T2, where T sub 1 is the initial kinetic energy and T sub 2 is the final kinetic energy. So let's draw the free body diagram on top of this space diagram. This would be the weight. Of course, there is a normal force, but the work of normal force is 0, correct? The work of normal force is equals to 0 because it is always normal. At point B, the weight is still downward and the normal force is still perpendicular to the surface. There is no need to resolve the weight into x and y components, because if you do that, Wy would be normal and therefore would create no work, and the Wx is the only component that would contribute to the work by the weight. But the curve path is not defined, and so we don't know the total displacement from point A to point B along that curved path. And since Wx and Wy come from the vector W, the work of the weight is equal to the work of Wy and Wx. So that would only complicate the problem. So we just have to solve the work of the weight using the 20 feet displacement as it moves from point A to point B. Okay? And of course, the friction force. The friction is always opposite to the motion. So if we isolate, this is the weight and the displacement is of course 20 feet, but for the Fk it is varying, but the displacement is we don't know the displacement. So let's plug them into the equation. That would be 1/2 m v1 squared and 1/2 m v2 squared. So this would be mass, which is 64.4 pound. Let's convert it to slug. 32.2 pound 1 slug. The initial velocity at point A is 3 feet per second squared. The work done by the weight is equal to 64.4 pound and the displacement is 20 feet. That would be positive because they are at the same direction. So for the friction, we don't really know the displacement, but the product of Fk and that displacement, that would be U sub F. So we write u sub f, and that would be negative because it is always opposite. The displacement is always opposite to the force, and that would be 1/2. The mass is 64.4 pound. Let's convert it to slug. 32.2 pound 1 slug times the final is 25 feet per second squared. So let's check the unit. Pound cancel, slug feet per second squared. It would result to a pound force. Okay, so slug feet per second squared, that would result to pound force, and of course there would be extra feet because feet squared, which is of course consistent with the foot-pound in the work. So finally, let's solve for the u sub f. The u sub f is equals to 672 foot-pound. So the work done by the friction as it moves from point A to point B, even though we don't know the whole track of crate, but the question is the work done, and that is scalar. The answer is 672 foot-pound.